it starts. And if you didn't start it yesterday, it's not a big deal. These are just kind of guidelines for when I thought you should start things. Definitely today after our chat, you probably want to jump into this activity because it'll be nice and fresh. So you are doing part 2 of this activity. So hopefully after number 9, you started to read. You don't have to do any of this stuff up here, but just showing you where it is. After number 9, there's this huge narrative for Judy and her sisters and what's going on and why she's going to be tested. So hopefully you read through this narrative, specifically this section on marker analysis and STRs, and then you're going to start the activity that follows. Things that you definitely need in order to do this activity. You need this PDF for sure. You need a ruler that has the ability to measure in millimeters. So when I first started doing this activity the other day, because I wasn't in class, I was like, oh my gosh, I'm not sure that I have that. But I did find a tape measure, and it does have millimeters on it, surprisingly. If you don't have a ruler with millimeters, this is going to sound kind of crazy, but there are websites you can go to where you can make a ruler. So it'll show you on the website how to take a piece of paper and hash it out with centimeters and then hash that out with millimeters. It's not going to be a perfect system, obviously. It's not going to be really precise, but at least you'll have something to measure with. But for the most part, I'm sure you all have some type of measuring tool at home. If you only have a ruler at home that does inches and not metric system, then you'll just need to use a converter to make sure that you get it into millimeters for your graphs. Okay, so you need this PDF, you need a ruler, and then you don't have to use the resources necessarily, except for you must have the graph paper, which looks like this. And I'll explain what my graph is here in a second. But this type of logarithmic graph paper is kind of crucial for making the graph. You can't make a graph on your own because logarithmic graph paper is curved. It doesn't look like it is obviously two-dimensional when we're just checking this, but this actual piece of graph paper is curved, and that's why it's more narrow in some spots and broader in others. So not really something that you need to understand fully, but just know that this piece of graph paper is important. If we're looking at this piece of graph paper, and we'll talk about this more later, on the y-axis you have fragment length. So this is in base pairs. So how big is the piece of DNA that you're looking at? And then your x-axis is your reference point. And that reference number is the one that you'll calculate, and we'll talk about that in a second. Okay. The last thing you might want to download, I like it better because it's more concise, is the actual student resource sheet that comes along with it. That's in your resources, and I sent it in the email as well. But this student resource sheet has all the tables you need kind of concisely together and the conclusion questions right underneath it. So I personally suggest downloading that. It's a one-stop shop. You just use that in your graph paper and you're done. However, because I'm asking you to annotate the gel, which is this one right here, it might be easier for you to just use the PDF, because if you scroll down, you'll see the same exact tables are in the PDF as well. There's table 1, table 2, and table 3, and the same exact conclusion questions are at the bottom. Okay, so that's all the resources you're going to need for the activity. The activity itself starts here at part 2. It talks about how to look at the marker analysis for your patients, and then you're following all of the steps that follow. I personally think that if you just go through step by step, it pretty much lays it out there for you. However, I'm going to talk you through it just so that you're clear about some of the things that maybe might be a little confusing. Okay, the first thing it asks you to do is measure all of the reference points for the different bands that you see on the graph, or I'm sorry, on the gel. Can I just get a thumbs up? You can see my gel and the rainbows and all that? Yeah, you guys are bored out of your minds. I get it. Okay. So when you're measuring, you want to measure from the same place every single time. So just trying to be consistent, that's going to be how you get the best results from this. So I chose the middle. So as you can see, like if I scroll in, I was trying to put my lines in the middle of each well, and then again in the middle of each of the different bands. As long as you're consistent, it doesn't matter. So if you're like, well, I would rather do it at the top, we'll just make sure that you're measuring at the top of each band. So just be consistent when you're doing your measuring. When it asks you in the chart to measure not only the distance migrated, that's how far like all of these different individual bands traveled. And that's my rainbow here over for my ladder, and then my 4 patients over here. That's all the lines that are migrated for those bands that have traveled. But then it also asks you to measure the distance to the reference point. The reference point is this dark black line at the very bottom. That's basically where the loading die from your different samples moved down. So if you recall from running a gel, there's usually like a dark blue or purple line at the front to show you how far it's run so far. So that's your reference point. And if you look over at my charts here, my reference points are all the same because that black line should be consistent. And again, if we were doing this in a real gel, it might not be exactly the same as it ran through. But for this one, since we're using the picture that they gave us of the gel, this is clearly a straight line. So all of your reference points are exactly the same. Okay, so I know that that was one question that everyone had. Next, as you're filling out the first table, right? So you have the distance to your reference point, that's what we just talked about. That's the actual gel length. And then the distance of each of the fragments of your ladder. So in this case, it tells you exactly what size each band is in base pairs. You're measuring how far each one of those traveled. So that's the rainbow up here. And you're going to do exactly this. Please annotate your gel exactly the same way. And I mean, you don't have to use the same color scheme if you don't want to, but I just want to see that you had some kind of rhyme or reason to the way you measured. So I used rainbow colors so that I could keep track of them. You don't have to do it exactly the same. But once you measure those in millimeters, then you will put that measurement and match it for each one of your fragments. Okay. Then once you do that, you'll do the calculation for your RF value. So that's, you're going to put that over here and round to the nearest hundredths place. So A divided by B for all of these and put them in this column. Okay, that's part one, and you just can put that off to the side for a second. And then you'll need to get your piece of graph paper. With your graph paper, open, thank you. With your graph paper, now you're going to plot all of those different points on your piece of graph paper, where again, you have the fragment length because they gave it to you in the first column, and then you calculated the RF value in your last column. So you'll use that information to then plot the points and draw a straightish line through. Mine kind of got a little curved. It could be an error in measuring. You're going to do a lot better than I am. So yours is going to look much nicer. Okay, once you finish that and you've graphed them on your graph, now you can use that graph to plot all of your samples from your patients. Because even though when we look at this gel, we could kind of line things up. Like if I was looking at this one right here, who is Jennifer's first band, I'd be like, oh, that looks pretty close to this. So I could sort of say that those match, but it's not for certain. Like they could be off a little bit. So the graph is what helps you decide exactly or more closely to exactly how big that particular base pair or that band is. So I would zoom out first. So I would, in table 2, I'm going to, again, do my reference points, which are going to be the same, right? Because it's that distance that the loading die traveled. So that's going to all be the same amount. And then I'm going to measure all the distances of each individual band for all of my patients, and those go here. I'm going to find my RF values again. So it looks very similar to this first table. The problem is we don't have the length and base pairs to graph them in the same way. So that's where the graph comes into play. You'll go over to your graph and you'll line up. So let's say that one of my patients, let's say Judy, one of her bands was 0.5 the reference was 0.5. So then I would go up from 0.5 until I hit my black line. And then I hit it, and then I can see how many base pairs that was by traveling over. So I'd say, oh, okay, so that particular band for Judy was about 490. Okay, hopefully that's kind of making sense. I'm going to leave this here and just ask someone to participate. What if I had a patient whose band came up as 0.7? Approximately how many base pairs would you say that patient's band was if their reference was 0.7?
About like 250 probably.
Yeah, beautiful. Yeah, I would agree. About 250. So whoever that was, I'm sorry, I didn't get to see who was speaking. But, oh, Franklin, thanks. So 0.7, she traveled up from 0.7. She hit the black line this is on my graph. And she traveled over and she saw, okay, it's about between 200 and 300, so she's guessing 250. And that's fine. Estimating is totally fine. Now, here's why your graph could look very different than mine. So for those of you that are thinking, oh, I'm a smarty pants, I'm just going to look at all of Miss Masonette's answers because I can look back at this Zoom. You can't, and here's why. Because you don't know how much I zoomed in, on this particular gel when I was measuring. So I did this on my computer, right? So I could have been measuring it like this, or like this, or like this, or like this, and that's all going to make different measurements. Now, hopefully will it end up the same in the end? Maybe, but this is why you can't just straight copy my answers. So let me make myself really clear that you need to do your own measuring for all of these. It's kind of fun, so hopefully you won't just like blatantly take my answers, but it's kind of fun to do. Okay, blah, 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 blah. That was chart 2. So now you found the approximate base pairs for all of your patients, and you can put them into table 2 down here. So once you look on the graph and you estimate, okay, let's say Diana's fragment, one of her bands was 250 and the other one was 300. So, well, 250 is not a great example, but let's say one of hers was 300 and one of hers was 400. So in order to figure out which allele is present, then you scroll down to look at this chart that tells you which allele is which. So I said she had a 300 and a 400 base pair band. So that means that she has allele 2 and she has allele 3. Okay? So that's basically, that's the entire activity, is trying to figure out which alleles are present. But the take home is that